All right, I think it's 3 o'clock. So today I'm going to be talking about deploying self-healing services with Kubernetes. My name is Rob Scott, Robert J. Scott on Twitter if you have any questions. And I work for and with a great team at Spire. We do corporate wellness products that help encourage happiness and healthiness in the workplace. Some of you may remember this great outage by AWS earlier this year. This is a screenshot I took of the status page partway through that day. And oh my goodness, there were lots of things that were having issues that day. It was a rough day. Was anyone on AWS that day by any chance? Yeah, okay, so yeah, it wasn't the best day. We were also on AWS. We were on US East 1, so we were kind of panicking a little bit, and I imagine we weren't the only team that looked something like this that day. It was rough. But as we kept on watching the status page and everything changing and everything looking like the world was burning down kind of thing with AWS, all our systems were still up and running throughout the entire thing. 2 hours in, everything is up and running, and we're feeling, okay, maybe we dodged a bullet, maybe we're good to go throughout this. But nothing is ever that simple. Couple hours in, we had an EC2 instance fail for us. And usually this isn't a huge deal. We just spin up a new one, it gets replaced, and we're all right. But unfortunately, part of this outage meant that you couldn't spin up any new EC2 instances, we couldn't replace anything, you were just kind of stuck for, in this case, a few hours until that outage finally went away. So we were not feeling that great at that point. But as we watched what Kubernetes was doing, since we were using Kubernetes on AWS, we were amazed to find out that all our systems were still up and running. And to give some context, before we moved to Kubernetes, this would have looked something like this for us. It would not have gone well. And I'm not saying that there aren't other systems that could help us like this, but Kubernetes really helped us out during this outage. So to explain exactly what happened here, first I want to give some basic background of what is actually powering our systems. So we've got 6 different services that power Spire. If any one of these fail, somebody's going to notice, and we're not going to be fully up and fully functional. With Kubernetes, this looks something like this, approximately. So in this example, we've got a 4-node cluster, so 4 worker servers that are powering 3 different environments. So we've got a demo environment, a staging environment, and a QA environment in this example. So what happens when one of these nodes starts to fail or become unhealthy? The first thing is Kubernetes recognizes this node is unhealthy, this server is unhealthy, so I'm going to stop sending traffic to it. Luckily, we had built in redundancy so that, okay, you see we had a staging management portal on node 4. We also had one running on node 3. So Kubernetes recognizes this node is unhealthy. I'm going to start sending all the traffic for the staging management portal over to this pod over here. And you can see throughout this list, we have redundancy built in across our other nodes. So that helped us a lot. Kubernetes recognizing, 1, this isn't healthy, and then 2, I'm going to redirect to where things still are healthy. That helped a lot. But then the next step is even better. Kubernetes recognizes, okay, none of these are useful anymore, so I'm going to pull them off of that node and move them over here. So it recognizes that node 4 is unhealthy. It takes everything from there, so we'll go back. It takes all of these guys, and it moves them over to our existing 3 healthy nodes. So we had enough capacity, and everything moved over seamlessly, and we're just sitting here amazed that we didn't have to do a thing. Kubernetes picked up everything, redistributed traffic, and then redistributed our pods without us doing a thing. So that was, well, incredible. But is it really that simple? You're probably asking because, well, that seemed a little too easy. And, well, it mostly is that simple. We didn't do that much extra to make that happen. But there's a few things I wanted to talk about today that really did help us out and that can help you out if you are using Kubernetes to ensure that your systems are really self-healing and can recover from these kinds of incidents. So the rest of this is really just going to be a big demo and basically explaining how Kubernetes works. So at the very base level, I'm going to talk about a namespace. And this sounds kind of, well, really basic, but just to give you an idea, the only prerequisite for this demo, the only thing I had before what's covered here is a Google Container Engine cluster, so a Kubernetes cluster. And you can go in, create your Google Cloud account. I don't work for Google, by the way, so I'm not advertising them, but you can create a Kubernetes cluster in around 2 minutes with them. Just click up a couple buttons. That's the only prereq for this demo. Everything else you're going to see in this highly available self-healing cluster is here. I'm not hiding anything. So with that in mind, I'm starting at this very foundational concept of a namespace. And in our previous example, we had a staging namespace, a QA namespace, and a demo namespace. So again, this is all the YAML config you need to create a Kubernetes namespace. And that's a way to group your pods, group your containers into some kind of environment. In this example, I'm calling this my self-healing K8s demo, K8s being short for Kubernetes. I'll use that a lot because I'm lazy, so it's there. And then you're going to see I'm going to call the Kubernetes command line tool. I'm going to apply that YAML we just saw, and we have a namespace. So we're up and running. We have something to put all our pods in now. But before we get there, we need to create a service. And this service is how you expose these pods to the outside world, how you create an endpoint that will actually direct traffic to your pods. So here's a very simple YAML definition of a Kubernetes service. So at the top, you see a kind of service. You've got a name. This is really cool. You've got a type of load balancer. So if you're on any kind of cloud, whether it's Azure, AWS, Google Cloud, this is going to create a cloud load balancer for you and manage it. So on AWS, like us, it creates an elastic load balancer for you and manages the ports and connections automatically. Yeah, that's a great question. So everything I'm going to be showing you is a YAML kind of config file. You can also use JSON if you'd prefer, but Kubernetes, you give it a config, you give it a state that you want it to achieve, and Kubernetes will do what it can to reach that state. Then the next thing in here is I've got this selector, self-healing K8s demo. And so that's saying any pod with that label is going to get traffic from this service. And then the service is going to listen on port 80 and then send traffic to our pods on port 3000. OK. So I'm going to go ahead, kubectl. You're going to get tired of seeing this over and over again, but we're applying our service now. So our service is created. A Google Cloud load balancer will be created since this demo is running in Google Cloud. And so we have an endpoint. And the last kind of element you need to actually serve traffic is the pod, the actual container itself. And a pod is Kubernetes' way of wrapping Docker containers or any other kind of container that Kubernetes supports. And again, you're going to see some very, very simple YAML config. I'm using my own personal demo HTTP server. I promise it's not fancy. It has like 2 routes. We're going to use both of them in this demo. And then remember before with the service, we had that label that said anything with this label is going to get traffic from the service. Well, here's the label saying I want traffic from that service. OK? So, OK. I've got to back up a little bit. For the rest of this demo, this bottom half of my terminal is going to have the output from watch, kubectl, get pods. Nothing fancy going on here. This is just getting a list of pods that are currently running while we're going through the demo. So just so you know what's happening down here, that's the command. It's going to run every 2 seconds and show you an update of what's happening. OK, so we'll get there eventually. There's no resources found because we don't have a pod, but we're about to fix that. Kubectl apply, and we're going to create that YAML we just saw for the pod. OK, the demo pod is created now. You see it running within a matter of seconds. And then we're going to go over to our browser, refresh, And this is my very fancy demo server. 200, everything looks good. It only ever says 2 things. So this is one of them. OK. So we've got our pod created, but what happens if something happens to that pod, if it crashes, or if it fails, or if it is deleted in this case? Well, it goes away. This is, by default, not resilient in any way. We're just running a pod, a container, so now when we try and refresh this, it's gone. The service has nowhere to go. It has no pod that's listening for it. So if anything happened to that pod, it would crash and go away. So that doesn't really tie into my kind of high availability Kubernetes stuff, but we're getting there. And this is where all the magic happens, deployment. And we're going to be using deployments for the rest of this demo, and I promise they're great. A deployment looks incredibly similar to a pod, except you see 2 big differences. One, you see a kind of deployment instead of pod, and then this little magic here, replicas of 3. So that means instead of just a single pod running, this is going to do whatever it takes to keep 3 of those pods running at any time. If a pod fails, if something happens, it's going to kill that pod and start up a new one automatically. So we'll see exactly how that works here. OK, so kubectl, we're going to apply this new demo with a deployment. Here it comes. Right away, you should see 3 pods coming up here. And we're going to go back to our browser, and we'll be serving traffic again with that very creative message I have. OK, 200, everything looks good. But our pod accomplished that. We need to go a little bit further. Let's go ahead and go through the same step again. Let's pretend this fails or just delete it. I will take this top pod here, get rid of it, and watch carefully what happens. A new pod's going to show up right there before this one terminates. So before it can even get rid of this one, we have a new one up and running to replace it. That's regardless of how it fails. It's going to get replaced automatically with Kubernetes because you've told it you want 3 replicas running in your deployment. All very automatic, all very cool. OK, so hopefully it's mostly ops people in here and not developers, because sometimes developers write bad code, I being one of them at one point. And sometimes, let's just imagine these developers write some kind of route that just absolutely destroys or crashes your server just when this one route is hit. I have that with my demo server, so let's try that out. If we go to /crash, it does that. It crashes the server, the process dies, and before we could even get back over here, notice how this pod has a restart count of 1. Kubernetes recognizes right away this process died. I need to restart it. It restarts it, and things are back up. So the only request that fails here is that initial crashing request. Kubernetes recognizes this process died. I'm going to spin it back up. We're back up and running without anyone else even knowing there was an issue. But let's say something fails a little less obvious. So if I go to /fail, it just returns a 500 for every single response from that process. So every single thing is going to return 500 from now on. But unfortunately, Kubernetes has no clue. It doesn't care. All Kubernetes knows by default is that the process is running. It doesn't know that it's working as expected. All it knows is this process is running. I'm going to make sure it continues to run. So we need a little help from a thing called liveness probes. This is the first of 3 key concepts I want to go over today. Liveness probes are incredibly helpful for detecting failures that may not involve a process actually crashing. OK, so the liveness probe config, again, is some very simple YAML. And so I'm just adding this to the bottom of my deployment. In this case, I'm doing a GET request on /alive. I'm running it every 5 seconds. And if it takes more than 1 second to respond, it's a failure. Or as is default with this kind of GET request, if it's not a 200 response or 204, something like that, it will also fail. So let's see what happens when we run with this new liveness probe on our deployment. So we're updating our deployment. The new pods are running. The old ones are going away. We'll come back over to our browser and hit that fail route again. So we'll go to /fail. Well, momentarily we'll go to /fail. And 500, something bad happened. We'll go back to our root, and still this specific process is failing. If we watch, I think it's one of these guys. Yeah, this one. It goes into an error state. The liveness probe failed. It restarts, and it's back up and running. So now if we go back to our browser, it's going to refresh, and we're going to get a 200 response. So very simple, but again, with that liveness probe, it's telling you, this thing failed, I need to restart it, Kubernetes restarts it, and you're back to a successful application. So who knows what could cause this kind of failure, whether it's a database connection, who knows, this is probably a more common use case for how your process will fail, and liveness probes become incredibly helpful. All right, so here's an example. Let's say you have a slow server that doesn't start immediately. This happens all the time. My example may be a little extreme, or maybe not extreme enough, but an environment variable my demo server accepts is startup delay seconds, and it says 40. So basically, when I apply this deployment, the new servers aren't going to respond to anything for 40 seconds. They're going to simulate something that just has this really long startup process. Fairly common. Hopefully not 40 seconds, but have to do something. So we're deploying our new stuff. You see the new ones are running automatically, and the old ones are going away. But of course, 40 seconds hasn't gone by yet. So when we come over here, Safari can't connect to the server. We can't connect anything because all Kubernetes knows by default is wait till your new containers are running, then get rid of the old ones. So these are technically running, but they're not ready to respond to request. So that's not very helpful. Well, of course, Kubernetes has something for that as well. Readiness probes. These are, of everything I'm talking about today, these are probably my favorite thing. Second of three major concepts I want to talk about. And these readiness probes look incredibly similar to a liveness probe. The config is basically identical. In this case, I'm going to hit a slightly different path. I'm going to run it every 5 seconds again. And if it takes more than 1 second to respond, it's going to fail. Okay, so let's go ahead and try this same thing all over again, but this time with readiness probes. Watch very carefully what's happening. See these two? These are new, but they're not ready yet. So it's leaving 2 old ones, these 2 here, running until these guys start to get ready. Okay, these guys are ready. The old ones go away, and it's spinning up 1 new one. And we come back over here. Everything looks good. And I couldn't show both at the same time, but trust me, it was a 0 downtime deploy. And one thing that people don't always think about with 0 downtime deploys and readiness probes and these kinds of things is they also help with what I like to call 0 broken deploys. So you notice how, as that was happening, 2 old pods were still keeping around. So if somehow your readiness probes never succeeded, if your readiness probes were actually checking enough, you'd prevent any kind of broken deploys. Let's say you didn't configure things properly. Let's say there was some kind of broken image that made it all the way through your QA and test process. It's not going to get past this last sanity check. This is very helpful, and hopefully not only will allow you to have 0 downtime deploys, but will help you have 0 broken deploys. Okay, so this is fun. This is my last example. And this is a little thing called Mayhem that I created. And I really hope you guys never, ever use this for yourselves on your own system. And definitely don't blame me. If you do, consider that a warning. Mayhem has no purpose that is useful at all, I promise. All it does is eat up all the resources it possibly can. And, well, that's it. So this is really to highlight how things can go poorly. Let's say you have some kind of poorly behaved service that gets into some kind of infinite loop and starts eating up all your resources. Hopefully you've never had this happen to you before, but I know I've seen it and maybe been the cause once or twice, and it's not fun. So in this case, I'm going to say 5 replicas, and you notice this deployment name is ever so slightly different. We're calling this a Mayhem deployment. So instead of replacing our existing deployment, this is going to create a new deployment to run alongside the demo deployment we've been working with. So let's see how effective this is. We're going to apply our Mayhem deployment. Got these 5 ones up and running immediately. They love to eat up resources. We're going to fast forward a bit. It's going to get to around a minute, so it can eat up all the resources it wants to. And, OK, we're trying to request our demo server, our demo deployment. And would you look at that, it's timing out. It has no resources left for itself. Mayhem has eaten up all the resources on the cluster, and there's nothing left for the service we actually want to use. That is less than ideal. This can happen. This is not a problem unique to Kubernetes by any means, but it's something that we need to be able to plan for, especially because Kubernetes encourages us to combine lots of different things onto the same cluster. And if you have one bad thing on that cluster, you can be into a real world of pain. So there's resource limits. They're great. I highly recommend them. The definition is very, very straightforward. You just add this to the bottom of your deployment. You say, I want to request 64 megs of RAM. I want 1/8 of a CPU. And in this case, I also have the upper limits set to the same thing. So the requests mean this pod will only get scheduled on a node that has that many resources remaining. And the limits mean this is going to limit it to this specific value. OK. So let's try the same thing. And this is kind of fun. You got to watch these bottom 5 that are about to pop up, and watch these 2. So they run for a few seconds, out of memory killed. Just restart, out of memory killed. We'll get there again, crash loop back off, out of memory killed, out of memory killed. You're going to see this over and over. They've restarted a couple times already. They're going to restart again, I guarantee it. Restarted 3 times, out of memory killed. And you get the process here. Notice 1, 2, 3. These 3 didn't even start. OK, and everything looks good back here. Everything looks good. So let me come back here for 1 second. 1, 2, 3 of these never even attempted to start. These 2 failed so miserably, Kubernetes wasn't even going to try to get the remaining ones up there. It generally only tries with 2 at first, and if those 2 succeed, it's going to start getting more and more out there. But it helps you from yourself and helps you prevent from breaking these things. So again, with these resource limits in place, instead of breaking our demo deployment, this remained isolated and continued to work, and these failed, but that's what we wanted to fail. Resource limits are incredibly helpful in this world. All right, so I've got a quick recap here, and I really just wanted to go over the 3 things I mentioned. The first was liveness probes. So when these probes fail, Kubernetes is going to attempt to restart the container for you. So these probes can be an HTTP GET request. They can be a bash action that you execute on the pod itself. There's lots of possibilities here, but the key is whenever they fail, Kubernetes is going to attempt to restart the container for you. The second concept I brought in was readiness probes. And Kubernetes doesn't send traffic to the container until these probes actually succeed for the first time. But it's even more important to that. With a deployment, Kubernetes isn't going to get rid of your old pods yet until your new pods are really ready to go. So as I say, 0 downtime deployment is great. 0 broken deployment is possibly even better. It makes sure that it still has working pods for you. And if these new ones never work, that's fine. It's still going to keep on serving traffic with your old pods. Whether you have a configuration error, whatever it happens to be, these are going to help you out. I highly recommend giving these a shot. And then the very last thing with that Mayhem example, without enforcing any kind of proper resource limits, any single rogue container or deployment can really take down your cluster or your node. Fun story with that Mayhem example there. That actually destroyed my node so badly. I've done it 3 or 4 times, and each time I've actually had to either restart or replace my server because it was that screwed up. So Mayhem is very effective. I take credit for that, but just be warned that it can get you in a bad spot. So with proper configuration, Kubernetes services can heal themselves. We've really benefited from using Kubernetes. Incredibly grateful that they kept us through that service disruption. And hopefully this is useful to you as you look into maybe trying out Kubernetes or if you're already on Kubernetes. Yeah, thanks for coming. Do you guys have any questions?
In practice, what kind of differences do you see between your liveness probes and your readiness probes?
Yeah, okay. So, oh my goodness, the amount that could be written on liveness probes and readiness probes, that's a great question. Readiness probes and liveness probes both work independently, and theoretically they're both supposed to, well actually they both do run consistently. What I've noticed in my testing is readiness probes don't do anything after a pod is initially ready. Once it's marked as ready, that pod is going to continue to receive traffic, even if it, at least right now, even if it eventually stops being ready. If the readiness probes fail later on, the pod is still getting traffic. I don't think that's by design, but in my testing on Kubernetes 1.6, that's what's happening for me. Liveness probes, one of your questions may be, okay, so liveness probes restart a container every time it fails. What if it fails consistently over and over and over again? Are you going to end up with something like mayhem where it just eats up all your resources and gets you into more trouble? Generally not. Kubernetes is relatively smart, and the first time it will wait 10 seconds to restart. I think the next time is 20, the next is 40 seconds, and it does a back off, so it's not going to eat up your resources by trying to restart so often. That does mean that if your thing fails every minute or two, each time it restarts is going to take longer. So that recovery is going to take longer over time, but probably better than the alternative of getting into some kind of restart loop. Yeah, great question. Anything else? Okay. Well, hopefully I got you guys to happy hour a little early, and I'll be there if you guys have any questions. But thanks for coming out.